somebody asked a minute ago, because I've been kind of a fanatic about this limit notation stuff, and somebody said, do we need to do that for this problem? And I said, no, but let's go ahead and do it. The way that problem will be worded is something like, use limits to describe the function behavior. So in other words, use limits to talk about what's going on in this picture. So you're always going to talk about your end behavior, so that's going to be one of your limits, or one or two, I guess, one on each side. And then we also talk about the behavior at the vertical asymptotes and the holes. So we have a vertical asymptote at -1. So we'll talk about what happens on the left and the right side of that. And then we have a hole at 3. So we'll talk about what happens on the left and right side of that. Now, the hole is actually the easiest one because you've already done the work. What is happening as we approach the hole, x equals 3, from the left and the right? What's y doing? Y is getting closer and closer to 5/2. So that's easy. Once you have found your y coordinate, that is what that's how the function's behaving. It's going there to that y coordinate. Now, what about the rest of this? You have your picture already. These are easy. What's my end behavior? Going to the right, I'm getting closer to 2 from the top. Remember, limit values are y's. These are y's. So I'm getting closer to where y is 2. On the other side, I'm doing the same thing, but from the bottom. All right, then my vertical asymptote, what's happening to my y values? Well, on the left, they're going down, and on the right, they're going up. Does anybody have a question about that? So again, one more time, what's that vocabulary going to be? Use limits to describe the behavior of the function, or the function's behavior. Got it? All right, one more thing that I haven't been emphasizing and I need to, and that is, let's go back to our problem right here. What is the domain? If I ask you to fill in the blank, what is the domain? What would you say to me? Daniel?
Infinity to positive infinity.
Negative infinity to positive infinity. That's our starting point. What that means when he saes that is, x can be absolutely anything I want it to be. Is that true?
No.
Why not?
There's a vertical asymptote.
There's a vertical asymptote. The kids, there's more than that. There's also a hole. And both of those are excluded from the domain. If you look at your original problem, you can't put in -1 and you can't put in 3 because either of those numbers in the original problem would cause it to be undefined. Would you agree with me? So what's our domain? Let's revise this. It's almost everything. It's almost everything. It's going to be negative infinity to -1, and then -1 to 3, and then 3 to infinity. Every discontinuity, removable or not, a hole is a removable discontinuity, a vertical asymptote is non-removable. Every one of those is excluded. Throw it out. So your domain is everything else. We got it? Anybody want to tackle the range? What's the range of this function?
Negative.
Yeah.
Be negative infinity to, and then 2 to 2.5, and then 2.5 to infinity.
You are the winner. Julia says, look, this arrow goes down, 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 down. That one goes up, 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 up. So in the beginning, I might think my range is all real numbers because I'm going all the way down, all the way up. But if we look a little more closely, it's broken at 2. So it goes from negative infinity up to 2. But then it stops. But then it goes from 2 to positive infinity, except for 5 halves, because that's an open out there. Awesome job. Awesome. Okay, all right, enough of that. Get out your 1.11 notes. And we just did the front page of that. I mean, a different problem, but basically you did it. So I want to look at example 4. So we're in our 1.11 notes. And I'm looking at example 4 because we are going to write our own equation now. So what I just had you do was I gave you an equation, you drew a picture. That's kind of what we've been doing a lot. Now, they've given us the picture. Looks like I have a vertical asymptote at 2 and a horizontal asymptote at -1 and a hole at 1, 2, 3, 4, -1/2. I count right? 1, 2, 3, 4, yeah. All right, let's start building an equation. Can we do that? What's going through your mind?
Put x plus 3, or x minus 3 on the top, put 0 zeros.
Okay, there's a 0 at 3. So whatever's going on, I gotta have an x minus 3 factor at the top. Would everybody agree with that? Okay, good, great start. On fire today, Julia, good work.
X minus 4 on the top and bottom.
X minus 4 on the top and the bottom, because why?
Because there's a hole.
There's a hole at 4.
X minus 2 on the bottom.
X minus 2 on the bottom, why?
The vertical asymptote.
There's a vertical asymptote there.
Let's have a 2 as the coefficient on top, because the 4 is on top.
Did you catch that, guys? If the horizontal asymptote, oh wait, the horizontal asymptote's not at 2. The horizontal asymptote's at -1. Julia, is that okay? Is that what you meant?
Yeah, I just switched up the
Okay.
vertical.
Yeah, the vertical's at 2. That's how we got this. But the horizontal's at -1. So if I, just what I have so far, and I don't know if we're done or not, but what I have so far, if I FOILed this out, I'd have a -x squared over a positive x squared. That would give me an asymptote at -1, okay?
There's a, y-intercept.
So I have a y-intercept. Now, my y-intercept was, I think it's like -3/2. Now, what does that mean? That means when I plug in 0, I need to get -3/2. Now, I'm actually not sure if that's -3/2, and I'm also not exactly sure that's -1/2. I think I'm gonna do this one right here. I think I'm gonna count on that being -1/2. I can't really tell in the picture for sure. So one of these points I have to use to figure out if I need to make any adjustments. Am I making sense? I don't know what happens here. Let's go ahead and cancel out our factors. And what I have is this. What happens if I plug in 4? If I plug in 4, do I get -1/2? Oh, I do. Just for kicks, let's plug in 0. If I plug in 0, do I get negative 3/2? Perfect. So this is the equation. You guys built it, you did great. In that situation, I would always go with the whole first, because that's a point they have purposefully put in there. Beautiful. All right, try 5 on your own. Try 5. Same kind of thing, only different. Anybody have a start? Where did you start with? Did you put an x minus 2 on the top and the bottom? Okay, what else did you put in there? Another x on the bottom because you have a vertical asymptote at 0. And maybe another x, or put an x minus 3 on the bottom. Good, 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 good.
X minus 1 on the top.
X minus 1 on the top because we have a 0. Now, I want you to look at what you've got so far. You're on a roll, you're doing great. You've got x squared on the top, and you have x cubed on the bottom. Does that jive with this right here? It sure does, because if your asymptote 0, your horizontal asymptote, that means that your power on the bottom is bigger. So we've got that. Okay. All right. What now? If you get rid of those, this is what we essentially have. Would you agree? And if we put in 2, we better get a half. Do we? A 1 over negative 2. Oh, shooty tooty.
You have to square the x minus 3 on the.
We're gonna square x minus 3.
Oh wait, never mind. Would you add an x to the top and bottom so you x over x squared? We're just making.
So let's talk about what just happened. What happened is I put in 2 and I got this point right here. But I need it to be that point, right? So how do I flip something over the y-axis, or the x-axis? How do I flip something over the x-axis?
Put a negative in
I make it negative, alright, so let's try that. Now, putting a negative in, I just made the top, put a -1 on the top, I could have put it on the bottom. Is that going to change my horizontal asymptote? No, because it's
Higher
zero, right? It's 0. So now I know that if I put in 2, I get 1/2. Alright, do me a favor, take your calculator out and sketch this guy right here. In the answer blank, you would have to have the whole problem. But in terms of graphing it, we don't need to have that computed factor in here. But I wanna make sure that when you graph that, it has end behavior that we're seeing here, asymptotic behavior that we're seeing here on this. What do you think, did it come out? I think we got it, don't you? Good with that? Alright, now I need you to go to, that was example 5, I need you to go to example 6. And we are going to find the slant asymptote. So let's stop for a second. He told us in the problem we have a slant asymptote, but you would know that already, right? By looking at the problem, because the power on top is 1 bigger. Alright, so he wants us to use long division, so we're gonna go ahead and do long division. I know we went through this a couple times before, but just to make sure, let's see, I made a 3x, so that when I times, I get 6x squared, that's my goal, right? And then plus 3x, 3x times 4. I hate long division. Did you get what I got? Okay, and remember when we're doing our slant asymptote, the remainder isn't important. Your equation would be y equals 3x minus 1. Is that all right? Okay. So now we're gonna do example 7. And we're not only gonna find the equations for the asymptotes, but we're gonna actually sketch it. So number 7, we are going to actually sketch. So, we gotta go through all the same stuff that you went through. On that, at the beginning of class with that piece of paper, okay? So here's our problem. What do you think I ought to do first? Excuse me, you have to try to factor it. Alright, so here we go. Let's see. I can take out an X. How does that factor? X.
Plus 6 minus 2.
Okay. And 6 plus 1. Okay, this is joyful good news. Our problem's gonna be smaller now. We are going to have to put a hole in for it, which we'll do here in a second, and it will be at -6. But now I've got x minus 2 over x plus 1.
So with the right factor form, do you want us to keep the hole in there, or?
In factor, this would be in factored form, okay? I'm moving on. So that's my completely factored form, okay? So I'm gonna have a hole at -6, and I went ahead and wrote this because I'm gonna try to figure out what that y is. So I'm gonna plug in my -6. Did you get -48 over 5? What is that? Somewhere between 9 and 10? Great. So -6. Oh wait, it was -48 this, crap. So far, so good. What else is in my picture? What have I got here? Look at what we got right here. What else can I put in? Vertical asymptote at -1. X equals -1. And x-intercepts actually at 0 and -2. That guy would also function as a y-intercept. What?
Does yours be positive for 2?
Oh, it should be. Thank you, Abby. Thank you. Now-
Horizontal asymptote, but 0?
No.
Or vertical asymptote for 0?
No. Remember, vertical asymptotes come from the denominator. So there's only gonna be one vertical asymptote. There looked like originally there might be 2, but one of them's a whole. So that's the only vertical. And look to the power on top. I'm gonna multiply this out. My problem is x squared minus 2x over x plus 1. So there is no horizontal asymptote, it is going to be slant. So I'm gonna do my division. Is it okay if I do synthetic division here instead of long? So -1 and 1, -2, 0. I'm gonna go ahead and put that 0 on the end. Drop my 1 straight down. And stop. Did I make a mistake there? Did I get all that? Is that okay? So what does that mean about my end behavior asymptote, my slant asymptote? It's going to be y equals x minus 3. So I'm gonna sketch a line with a y-intercept at -3 and a slope of 1. Yeah. Does that look okay to everybody? Sometimes people get confused by this. Remember, this is a function. So nothing can be on top. You can't draw any part of the curve on top. It has to pass the vertical line test. So the vertical asymptote is the divider. So there's going to be something on the right side and something on the left side of your vertical asymptote. So there's only gonna be one thing over here. And the thing is either gonna be in this part of the graph, you see what I'm talking about? Or it's gonna be down here in this part of the graph. Well, what's your guess? Well, I got a hole sitting down there, so I'm thinking it's down there, but there's even a bigger reason. Why can it not be up here? Because if it were up here, remember, it has to follow its asymptotes. So if it were down here, wouldn't it have to have an intercept there? And Addie said there isn't one there, right? So it's gotta be down here. So what's it look like? I don't know. That's some kind of weird shape, but it has to follow its asymptotes. So it comes up and goes down. Now, what's happening on the other side of the asymptote? Well, again, it's either in this section right here, or it's down here in this section. So what's your thought on that? It's gotta be up here, because you got 2 points up here. So what's it doing? Coming down, going through that one, coming down at some point, and going through that one, and out it goes. If at any stage of the game I get confused, what do I always do? If I'm sketching and I really am confused, I will simply plug in some points. That's right, plug in some points. Are you okay with that? All right, let's do some multiple choice now. Example 8. Multiple choice. See if you can figure out the right answer. Well, I'm probably gonna have to do a little work. At least I think I'm gonna have to do a little work there to figure that out. What do you think? Have you figured it out? And what do you think it is?
C?
C? What's C say? Has a slant asymptote. Wouldn't this definitely have a slant asymptote? Because isn't, if I look at my original, isn't the power on top x cubed and the power on the bottom x squared? So I think we have a slant asymptote, I agree. Okay, one hole and one vertical asymptote. Where's the hole?
Somewhere where X equals 1.
Somewhere where x equals 1. Okay, so let's just talk about that. How do I find the y, the somewhere? How do I find the y value?
You can't do that.
You can't do that. So you canceled, but did you actually remove that factor from the problem? No, because you had 2 of them. There is no hole in this problem. Because when you're still stuck with x can't be 1. Even when you tried to take it out, you couldn't. No hole. Do we have a vertical asymptote? X equals 1. I think the answer is D. Does everybody understand that now? You gotta be careful, and it's my fault, because I have led you to believe that when you cancel, you have a hole. But a hole is a removable discontinuity. So it's only a hole if you can get rid of the problem. And in this case, we can do a cancel, but we still have the problem. You see what I'm saying? Okay. 9. Let's go, let's try to get going here. 9 is sketch a picture of the, oh, okay, all right. Take a minute and see if you can sketch a picture. You're not writing an equation, you're just sketching a picture based on this information.
See how much was left.
As you're thinking about this, what's this? What's going on here? What does this tell me I have in my problem? A vertical asymptote. So I hope you put a vertical asymptote at -1. And not only that, but on the right side of your of that asymptote, you're actually on both sides you're going down. What is this telling me? So this is your end behavior, right? So as I'm going to the right, my picture is shooting down. So and as I'm going, no, oh wait, I copied it wrong. Which one of these is negative? This one, yeah. So as I'm going to the right, my picture is going down, but as I'm going to the left, my picture is going up. So I'm thinking maybe there is some kind of a slant asymptote going on here. So that on the right side, it's going down, and on the left side, it's going up. Does that make sense to you? Does that make sense? Everybody okay with that? Okay, all right, I'm gonna stop there because we have one more thing to do in this section, and it is kind of completely different and unrelated, sort of, so we'll do that. But, we'll pick up there next time. All right, so get your stuff gathered up. And